Hello, in this short video we are going to investigate the following challenging problem on the topic of binomial expansion. Let alpha and beta be positive numbers such that alpha cubed plus beta squared equals 4. If the maximum value of the term independent of x in the expansion alpha x to the power of 1 over 9 plus beta x to the power minus 1 over 6 all to the power of 10 is 10 times k, then k is equal to, pause the video at this point and try to solve the problem yourself first and see which one of the following options is the correct answer to the problem. Okay, now let us solve the problem. So this binomial to the power of 10 is given, and we know that alpha cubed plus beta squared is 4, and we also know that the maximum of the term independent of x in this expansion is 10 times k. We're supposed to find the value of k. Okay, so let me write the binomial theorem formula here. So if a and b are real numbers, and if I raise this binomial to some natural power n, this becomes sigma. K goes from 0 up to this n. N choose, okay, sorry. I have used the letter k here, so let me change this letter to m. N choose m, and then I have the first term to the power of n minus m times the second term to the power of m. So let me use this standard formula to expand this. So alpha x to the power of 1 over 9 plus beta x to the power of minus 1 over 6 to power 10 becomes equal to sigma. M goes from 0 to this number 10. And then I have n, which is 10. Choose m. A is this expression, so it is alpha x to the power of 1 over 9 to the power of n 10 minus m, and then this expression beta x to the power of minus 1 over 6 to the power of m. Okay, now let me try to simplify this a little bit. So this becomes sigma m goes from 0 to 10. I will here I have alpha to power 10 minus m, a constant. And here I have beta to power m, another constant. And I have 10 choose m, another constant. I write all constants next to one another. And then here I have one x here, another x here. These exponents will be multiplied. So it becomes 10 minus m over 9. And this will be minus m over 6. But because the bases are the same, I can add the exponents. So x to this power times x to that power. I write one x, I add the exponents. But I am looking for a term which is independent of x. So I have somehow to get rid of x. The only way that I can get rid of x is to put the exponent of x equal to 0. So this means that 10 minus m over 9 should be equal to m over 6. I simplify this by 3. I simplify this by 3. And then I multiply this here, so it becomes 20 minus 2m equals to 3m. So I move 2m to the other side, so it becomes 5m equals to 20, so m is equal to 4. Yes? Now that m is equal to 4, when I put the m equals to 4, of course this will vanish. This becomes 1, so it becomes independent of x. But I also have to put 4 here, here, and there. So the term independent of x is equal to, I put 4 here, alpha to power 6. So let me write this one first, if you don't mind. So this is 10 choose 4, alpha to power 6, beta to power 4. So this is the term independent of x, okay, without considering this condition. But now I want to calculate the maximum of the term independent of x under this constraint, and according to the problem, that maximum is 10 times k. But how can I calculate the maximum of this? So I want to use the very simple version of the geometric arithmetic inequality. So if x and y are positive real numbers, we know that the arithmetic mean between these two numbers is always greater than or equal to the geometric mean between the same two numbers. It is extremely easy to prove this inequality. You just need to raise both sides to power 2 and simplify it. This inequality will be equivalent to this trivial inequality because x minus y to the power of 2 is always non-negative. So you can start from there and prove this inequality. Okay, but this is valid if x and y are positive. Okay, and it was mentioned in the problem that alpha and beta are positive. So what I can do, so let me do it in this way. Let me replace x with alpha to power 3, and let me replace y with beta to power 2. One thing that is important is that this equality can be satisfied if x and y are equal. So in principle, the maximum of the geometric mean is x plus y over 2, and the maximum occurs when these two variables are equal. So now if I choose x to be alpha cubed and y to be beta squared, okay, and put them in this inequality, then I will write alpha to the power of 3 plus beta squared divided by 2 is greater than or equal to the square root of alpha cubed beta squared. But alpha cubed plus beta squared is given to me to be 4. So this becomes 4 over 2, which is 2, greater than or equal the square root of alpha cubed beta squared. I raise it to power 2, so this becomes 4 is greater than or equal alpha cubed beta squared. So this means that alpha cubed beta squared is maximally 4. Is maximum 4 achievable? Yes. That happens is if alpha cubed is equal to beta squared. And this is possible because if alpha cubed becomes beta squared, then this becomes 2 beta squared equals to 2. Beta squared becomes 2, so it means beta is square root of 2. So yes, it is possible that I have the equality between alpha cubed and beta squared under that constraint. But now look, I want to find the maximum of this expression. That is extremely simple. So here I raised both sides to power 2. So alpha 6, beta 4 is less than or equal to 16. So if I want to find the maximum of this, that is a constant, I have to find the maximum of this expression. But the maximum of this expression is 16. Okay? So that maximum is equal to 10 choose 4. Yes? So maximum, not the term. So the max, so let me write it like a little bit of sloppy notation. So the max of this expression becomes 10 choose 4 and then times 16. So that is the maximum value. But according to the problem, maximum value is supposed to be 10 times k. So this should be 10 times k, and from this I can find k. So let us do that again. So 10 choose 4, so 10k is equal to 10 choose 4 times 16. So let us solve this for k. So this is 10 times k. The right hand side is 10 factorial divided by 4 factorial, the difference between these 6 factorial times 16. But let us try to simplify that. So the left hand side is 10k, the right hand side is 10 times 9 times 8 times 7 times 6 factorial. But that 6 factorial cancel this one. 4 factorial is 24 times 16. 9 times 8, 72. 72 and 24 3 times. So, and this 10 and that 10 are cancelled. So I am left with k is equal to 3 times 7, 21 times 16. So I have to calculate that. So what is that? 10 times 21, 210. Yes. 6 times 20, 126. So what is the answer? So the answer will become 336. So that is the correct answer to this problem. Yes. So let us double check if we have that in the question, in the options. Yes. So 336 is the correct answer to this problem. Okay, so I hope that this video was helpful. Until the next video, be safe and goodbye. Thank you.